In our next example, we're going to take an added component to our problem where we're going to shoot the projectile upward at an angle of 30 degrees with the horizontal at an initial velocity of 20 meters per second, still from an initial height of 50 meters. The question still remains, how far will the projectile go in the x direction before it hits the ground? Now, since the projectile is thrown upward at an angle, you would expect that it stays in the air longer, it will go farther in the air. On the other hand, of course, that the x component of this is now smaller, and so each second it will travel a smaller distance in the x direction, so that will have a factor as well. But regardless of what's happening here, we always start out with the concept, how long will that projectile stay in the air? And so the question becomes t in the air, and the equation we use for that is y equals y sub naught plus v sub naught in the y direction times time plus 1/2 gt squared. Typically, we find the time in the air first, and that's the equation we then need to find that. So again, final height when it hits the ground is 0, initial height when it starts at 50, but now it does have initial velocity in the y direction. Before we can figure out what that is, we need to find the components of the initial velocity. So we need to find the initial velocity in the x direction. Oh, I say x and write y. That's nice. So in the x direction, and we need to find the initial velocity component in the y direction. Of course, in the x direction, it'll be the initial velocity times the cosine of the angle theta. And here, this will be initial velocity times the sine of the angle theta. So that becomes 20 meters per second times the cosine of 30 degrees. And this becomes 20 meters per second times the sine of 30 degrees. And of course, the sine of 30 degrees, that's equal to 1/2. So 1/2 times that is 10 meters per second. And then for the x direction, the cosine of 30 is 0.866. So again, 30 cosine and times 20, and we get 17.3. That's accurate enough. Let's just write it like that. So this is equal to 17.3 meters per second in the x direction. So now we have the initial components in the x and the y direction of the velocity. So you always need to do that as well. All right, now we can plug that in here. So it's a positive 10 times t minus 4.9 t squared. So now we have a quadratic equation we need to solve for time. And before we do that, let's rearrange the terms. Let's put this one first, and let's change the sign so that the first component will be positive. So 0 equals 4.9 t squared minus 10t minus 50. Notice I simply multiplied both sides by -1, and I rearranged the terms from highest order to lowest order. So now I use the quadratic formula. I know that t is going to be minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Of course, a, b, and c are the coefficients of the three terms. This coefficient is a, this coefficient is b, this coefficient is c. So when we plug that into our quadratic formula, we have t is equal to minus b. A minus times a minus 10 is 10, plus or minus the square root of b squared, that would be 10 squared or 100, minus 4 times a, which is 4.9, times c, which is a minus 50, and the whole thing divided by twice a, that would be twice 4.9 or 9.8. Notice that this minus will negate this minus, make the second term in the radical a positive quantity. So we have 4 times 4.9 times 50. Add to that 100, which is 1,080. Take the square root of that, and let me write that number down. So we have time is equal to 10 plus or minus 3.286, the whole thing divided by 9.8. Something is not right. Let me do that again, because I think that was, oh, I see. My decimal place is in the wrong place. I was going to say that doesn't seem right. So 32.86, that's better. Now notice when you look at this, if I use the plus option, you get a positive answer. If I use the negative option, since this is bigger than this, you'll get a negative answer. Now you say, well, how can you get negative time? You can't go backwards in time, but really what that means is the negative answer will assume that the object started over here from the ground, was thrown up, and after that much time will have we'll hit this position with the exact velocity, height, and angle, so we'll continue in that path. So even though it's not really part of the real problem, it's kind of an imaginary answer that would be used as if the problem started from down here rather from up there. So it does have some meaning in a way. But for now, let's go ahead and take the positive answer, so that's plus 10, and divide that by 9.8, and you get 4.37. So this is equal to 4.37 seconds. But just so we can keep track of that, let's assume the negative answer. So we have 10 minus 32.86, and divide that by 9.8. And so that would be 2.33 seconds, so minus 2.33 seconds. So that would be kind of the imaginary answer, and we're not going to use that. All right, now we have time in the air. So for the second part of the problem, we're going to find out how far it traveled. So we know now that in the x direction, we have x is equal to v initial in the x direction times time. The v initial in the x direction is known right here, which is 17.3 meters per second. We multiply that times the answer we got here, 4.37 seconds, and 17.3 times 4.37 equals 75.6 or 76 meters in the x direction. And that's how you do that. So the only difference between this problem and the previous problem, where the object was shot horizontally, we now also have some initial velocity in the y direction. So we get a little bit more complicated quadratic equation to solve before we find time in the air. And that's how you do this problem.